இல்ல ஒரு நிமிஷம் வாப்பா.
என்ன பாரு ரெண்டு பஸ் போயிருச்சு. 2 3 4 ஆட்டோ போயிருச்சு.
Good evening to all. Once again, I welcome you all for our AICT Training and Learning Academy. Sponsor 6 days online faculty development program and AI assisted integration of renewable energy sources into EV charging networks at the Solomale College of Engineering, Madurai. So today, second day of our FDP. So today I also have 2 sessions. In first session, our resource person is Dr. V. Ravikumar Pandey. Associate Professor, Department of EEE, Amita Vishwa, Vidyabidam, Kollam. So before start the session, some introduction about our chief guest, Dr. V. Ravikumar Pandey. He is a senior IEEE member. He completed a BE degree in MEPCO Engineering College and completed MA degree in Annamalai University and completed in PhD in IIT Delhi. He served as a post-doctoral researcher at Master Institute of Science and Technology UAE from 2010 to 2015, and also he have more than 10 years experience in Amita Vishwa Vidyabidam Kollam. He have 37 international journal publication and 50 international conference publication and 2 book chapter publications. Welcome you, sir. Sir, can you hear me?
Yes, ma'am. Yes, ma'am. Thank you.
Welcome you, sir.
Ma'am, thank you for your introductions about me. I will start the sessions, ma'am. Thank you.
Okay, sir. Okay.
So today's sessions, I'm going to talk about AI-assisted vision and energy management system for grid-connected wireless EV chargings. So this is my profile. I would like to thank all my beloved teachers for giving their knowledge, transferring their knowledge to me so that I can, provide my understanding and learning here in this platform. I thank the coordinators of Solomalai College of Engineering, Madurai for these invitations and arranging all 6 days FTP. So this is my profile, as ma'am told already. So it's about my university, Amrita Vishwavidyapitham. It has different campus and different branches. Okay, let's move on to the actual content. Okay. So what I'm going to talk about in the today's session is, I'm going to talk about basic introductions and something like how the smart grid and EV integrations are related for the today's topic. And then what is energy management system? What are all the roles and responsibilities of energy management systems? What are the various control methods available in EMS? Then for EMS, how to implement EMS for EV charging stations? I'm going to give two different case studies based on my research related things. One is the ANN based EMS control for PV based EV charging stations. Then case study 2 is AI based misalignment detection and correction in wireless EV charging. Then I'm going to give the conclusions and some references related to this talk. Let's start with the introductions with the problems in the climate change. So as we know that the greenhouse gases which causes the climate changes, the IPCC, Intergovernmental Panel on Climate Change, projects that global mean surface temperature to increase by 1.4 to 5.8 degrees Celsius by 2100. So, which is the fastest rate of change since the end of the last ice age. Then the IPCC expects global mean sea level to rise by 9 to 88 centimeter by 2100. The UNFCCC, that is United Nations Framework Conventions on Climate Change, try to mitigate this issue through a lot of COPs and meetings. What is the challenges in the energy sustainability? With the global population swelling and industrialization on the rise in developing nations, humanity's hunger for energy has reached unprecedented level. So, more than half of our energy comes from fossil fuels extracted from deep within the Earth's crust, which makes, like so far, we have taken 135 billion tons of crude oils to drive our cars, fuel our power stations, and heat our homes. So transportation accounts for a significant share of global carbon emissions in the sustainability aspects. So the energy industry is facing decades of transformations according to the World Energy Councils. What is the targets, 2030 targets set by India? The government efforts to make India shift from a power deficit to an energy self-sufficient asset for several decades, and today more than ever the country is committed to seek alternative energy sources for sustainable development. For Indian government, 2030 goal to have a low carbon energy sources, 500 gigawatt of renewable energy capacity to cover 50% and 40% of energy and electricity needs respectively, and to reduce total carbon emission by 1 billion tons. What is 2070 target set by India? India aims to reduce or reach carbon neutrality, that is net zero, by 2070 as per Glasgow COP Conference of Party 26 meeting. This is the set value. So the net zero 2070, in order to achieve this, the usage of coal should be dropped by 99% in 2060 itself. Then only we can achieve net zero by 2070. And the consumption of crude oil across various sectors for the energy needs would need to peak by 2050 and fall substantially by 90% between 2050 and 2070. And also the green hydrogens, that is one of the other resources coming up recently, could contribute 19% of the total energy needs in the industrial sectors. So the long-term plan for 2070 target with 6 elements: expanding renewables and strengthening the grid, exploring the greater role of nuclear energy and alternative things such as hydrogens, green hydrogens, fuel cells, and biofuels. Then appropriate demand side measures such as energy efficiency improvements, rational utilization of fossil fuel resources, enabling a focused transition towards low carbon development. Then optimum energy mix, complementing national development scenarios. As we know that we are moving towards the smart grid scenarios from the traditional grid, how the smart grid will support the EV charging infrastructures, all those things. I'm going to connect that. Before connecting that, what is the difference between the normal conventional grid and smart grid? As per IEEE definitions, the smart grid is a large systems of systems where it has 3 layers. The first one is the power and energy layer. Then second one is communication layer. And the third one is IT or computer layer. So the layer 2 and 3, which is the major enabling infrastructures that makes the existing power and energy infrastructures smarter. So it will, smart means it will be best or optimal utilization of already available resources. What is the major characteristics of smart grid which is expected? Self-healing, flexible, predictive, interactive, optimized, and secure. So these are all the operations of smart grid. It can handle the tasks of classical power systems operations in an effective way. It allows for active customer participation to enable for better energy conservation. Example, demand response programs, DR programs, or demand side managements. Those things will be reducing or better utilization of the energy. Traditional grid, as we know that it is a load following characters, and smart grid we will move on to the grid following natures. So grid will decide the real-time price and customers will follow the grid. Then allow for the integration of renewable energy sources to address global climate change, and the smart grid allow for better utilization of existing assets for the long-term sustainability. Then it allows for the management of distributed generation and energy storage to eliminate or defer the system expansions to reduce the overall cost of energy. And also it allows for the integration of secure communications and control across the energy systems to promote interoperability and operational flexibility. What are all the enablers of smart grid? Smart meters at user end, smart meter network for AMI, smart data concentration units, MDMS, meter data management systems, and integration of MDMS with the SCADA units, and IT infrastructures to handle the MDMS. Then what are all the advanced components in the traditional power grid is needed? Advanced generation technologies or alternative generation technologies, advanced storage technologies, composite conductors, grid-friendly appliances. Then we need different control methods, better control of bulk generations, real-time monitoring, and control of power system stability, advanced control of distribution systems. What are the smart grid standards? I have given major 4 numbers here, which we will repeatedly encounter when we talk about the smart grid standards or renewable energy or smart metering and EV. The first one, IEEE 2030, this addresses smart grid interoperability with Task Force 1, Task Force 2, and Task Force 3 corresponding to interoperability in power systems, information systems, and communication systems. Then the IEEE 1547, developed in or established in October 2003, outlines the collection of requirements and specifications for interconnecting distributed energy resources. Then IEEE Standard Association created or introduced 2 new standards, IEEE 1701 and 1702, to create a multi-source plug-and-play communication environment for smart metering devices. Then IEC 61851, established in 2014, this specifies the requirements of DC EV charging stations. These are all the major standards which is needed for the smart grid environment. Some of the smart grid pilots or projects across the country, listed here with the consumers and cost of the projects, project area, in various places, IIT Kanpur, Amravati, Delhi, Kolkata, Puducherry, Meerut, and a lot of places, these meters and other things are implemented as the pilot projects or major projects. What is the National Smart Grid Missions says? Deployment of smart meters and AMI, and substation renovations and modernization with the deployment of GIS, development of distributed generation in form of rooftop PVs, and real-time monitoring control of DTs, and provision of harmonic filters and other power quality improvement measures, creation of EV charging infrastructures for supporting proliferation of EVs, then development of medium-sized microgrids. So based on the National Smart Grid missions, it is setting up the goal also for EV related infrastructure development. What is the roadmap for India? The Indian Power Ministry released vision and roadmap for India on September 10th, 2013, which spreads over the 12, 13, and 14 5-year plan periods from 2012 to 2027. The vision is to transform the Indian power sector into a secure, adaptive, sustainable, and digitally enabled ecosystems that provides reliable and quality energy for all with active participation of stakeholders. What is the 12th plan of 2012 to 2017? Completion of ongoing smart grid pilot projects, augmentation of data centers and communication network for AMI, then GIS upgradations using GIS, geographical information systems, then automated distribution systems, development of indigenous smart meters, then dynamic tariffs, sustainability initiatives promoting distributed generations. Then the 13th plan covers from 2017 to 2022 nationwide AMI rollout for customers greater than 10 kilowatt load, mandatory rooftop installation of solar generating capacity for large establishments, total renewable integration of 80 gigawatts, then improving the EV charging infrastructures, development of microgrids with total of 10,000 villages and distributed automations. Then the 14th roadmap plan 2020 to 2027, development of 50 smart cities, mandatory installation of rooftop solar generating capacity, total renewable integration of 130 gigawatts, 10% EV penetration, that is nationwide AMI rollout for customers, continuous research and development R&D, choice of electricity supplied by the customers. So with that, the EV in the smart grid target, it is major role in the Indian scenario. So what is the EV adoption status in India? the global and Indian status. Over 14 million vehicles already sales in the worldwide. Significant government incentives are given for rapid expansion of over 3 million public chargers globally, drive EV adoptions. In the Indian scenario, EV sales crossed in India 1.2 millions, and India aims for 30% EV adoptions by 2030 as part of its national electric mobility missions. So, the main challenge behind the EV adoptions or the lacking of the EV adoption is mainly created by the infrastructure shortage. By 2030, it is expected that the EV industry will cross 10 million EVs and adoption rate of 30%. In the context of 30 kilowatt-hour battery-powered car, energy consumption accounts to approximately 15 units of electricity. Charging EVs requires about 150 million kilowatt-hour of electricity daily. So the public charging station will necessitate nearly 100 kilowatt of load. And if we assume that 30 cars are served by one station, then we need 3,33,340 EV charging stations total in 2030. With this, the government is trying to give our support in terms of incentives. For example, FAME 1, 2015 to 2019, it was effective, intended to promote EV adoption with subsidies, however, was a little bit ineffective. Then FAME 2 brought in picture by the Indian government up to March 2024. It aims to develop of charging infrastructures with incentives for EV buyers and manufacturers. Then in 2024, EMPS, that is Electric Mobility Promotion Scheme, is introduced. But because of the charging infrastructure bottleneck, the mass EV adoption is actually a little bit challenging still. So let's move on to the energy management systems and how it is needed or implemented for the EV charging stations. What is EMS? Energy management system. Why it is needed? EMS is an computer-based system for monitoring, controlling, and optimizing the power systems. It's a very general explanations for the power systems aspects, EMS. Later we will see for how we can use it for electric vehicle charging stations. The key components of EMS will be RTUs, that is remote terminal units, then IEDs, intelligent electronic devices, then sensors in the hardware side, and control algorithms, network analysis programs are needed in the software side. These are all the key components for the implementation of EMS. EMS, it works alongside the SCADA for real-time system monitoring and control. So energy management systems is basically from the sensors data measured and given to the algorithms, computer algorithms, for better monitoring and controlling and optimizing the power systems. There will be three categories of objectives in the EMS. The primary objective being maintain system security and stability, keep power flow and voltage levels within the limits. That is the primary objective. So it is like with any disturbance occurs, immediately we will try to ensure that the system is stable and it is operating at the secure level. Then the power flow and voltage levels are at all the bus bars or all the lines are within the limits. That is the primary objective of energy management systems. Then secondary objectives will be it will ensure economic operations through optimal power dispatch, then implement real-time control for efficiency, better efficiency achievement. Then the last tertiary objectives will be that is very slow. First we need to fulfill the primary objectives always. Then we go for secondary objectives in between, then tertiary objectives. Tertiary objectives will be optimization of power system operations, or then planning maintenance schedules. So the functions of energy management systems will be control functions, operating functions, optimization functions, and planning functions. Control functions, it will be real-time monitoring, automated control. Operating functions, economic operation, decision-making support. Optimization functions, resource allocation and power scheduling. Then planning, load forecasting, maintenance scheduling, all those things are there. In this one, the primary objective, that is the first one, control functions. It is like real-time monitoring and automated control. Then the secondary objective, which I was talking in the previous slide, is covered with the operating functions, that is economical operations and economical decision-making supportive systems. Then the tertiary things are like resource allocation, scheduling, forecasting, maintenance scheduling, all those things are the tertiary objectives. What are the benefits of energy management system? Through implementing the energy management systems, we can improve the grid stability by real-time control. It prevents the frequent outages in the systems. It improves or optimizes the energy usage so that it reduces the operational cost, so it is much economical. Better decision making, because we have lots of data at each and every measurement points. So data driven control and planning, which causes the better decision making. Then enhance renewable integrations to operate the system in more efficient manner by installing the solar and wind-based energy generation systems. Then automation and efficiency improvement. By means of automating, it reduces the manual interventions and improves the response times. So it again increases the stability of the systems. So these are all the benefits of energy management systems. So this one is providing the overall EMS functions in a control center. So when we have the physical hardware systems, the power systems through remote terminal unit, the data will be communicated to the central systems through SCADA. Then SCADA will first go for state estimations. Then once the state is estimated properly, then the operator will go for following the online load flow, security assessment, stability analysis, and short circuit analysis. So there are some man-machine interface in this EMS systems. As you know, this very standard role of EMS in power systems. The same picture, whatever given in the previous one, it is from the Wooden-Muhlenberg very standard one, which is I showed you here. So whatever the SCADA substation data or remote terminal units data, telemeter data, first it will go for network topology program, and then state estimation will be there. From the state estimation, it will given to the economic dispatch, optimal power flow to the AGC control. Then okay, then the contingency and security constrained OPF or short circuit analysis, those things will be carried out. Okay. So we know that the basic algorithms of traditional power systems that also will be used here: unit commitment, economic load dispatch, power flow analysis, and the optimal load flow, and state estimations to know the complete state of the systems and avoid the errors in the measurement, the telemeter data. Those things will be avoided. Then contingency analysis to increase the power system security and reliability. Then AGCs and LFCs, automatic generation control and load frequency control, for the primary loop of control algorithms. So the classifications of EMS in the electric vehicle charging stations, EVCS, which I mean here is electric vehicle charging stations, based on the charging infrastructures, residential charging EMS or public charging EMS or fleet charging EMS. Based on the control strategy, we can classify into centralized EMS, decentralized EMS, and hybrid EMS. Centralized EMS means single control center managing all charging points. Decentralized EMS means each charger makes independent decisions. Hybrid EMS is combination of both centralized and decentralized. What are the key challenges of implementing EMS in electric vehicle charging stations? The load balancing, that is the most and important challenge. Optimizing power distribution among the chargers, that is the load balancing. Then grid stability, reducing peak demand impact on the grid. So how the grid stability can be achieved, that is another challenge. Then renewable energy integrations, optimizing solar wind power usage. Then battery storage management, that is optimal charging or discharging strategies. Then user demand response, pricing based control strategies. So these each and every items listed here can be taken as key challenges in the EMS for EV vehicle charging, electric vehicle charging stations. What could be the control objectives in EMS with respect to different point of things? First one is given as utility perspective or DSO perspective, distribution system operator perspective. Second, the middle one is EV charging station perspective, and the third one is the user's perspective. In the perspective of utility, the control objective could be economic dispatch, unit commitment, optimal power flow, demand response. In the charging station owner perspective, minimize operational cost of the EV charging stations, maximize the QoS, charging schedules, ancillary services, and demand responses. Then the user's perspective, demand response, improve energy efficiency, minimize electricity bills. So the objective of EMS will vary depending upon the perspective of the implementing authority. Either it may be utility or charging stations or maybe the users. As I told you already, the centralized and decentralized controls strategy in EMS. What is the benefit of centralized control and what is the benefit of decentralized control? As you can see here, the centralized control will have the PV, wind turbine, and residential EVs like this. Small microgrid A and microgrid B will be there. Then energy management system A and B are there. A and B are there. With DSO, all the informations are centrally controlled. Whereas decentralized one, the EMS A will take its own decisions individually and EMS B will take its own decisions individually. There will be some level of information exchange between the EMS A and EMS B. So level of information shared in the centralized one is detailed, and here it is limited information are shared in the decentralized case. Communication burden in case of centralized, it is very high, and here less information are shared, it is communication burden is low. Collaboration is possible here in both the cases. Biased solution is not possible because all the informations are available in the centralized locations. So biasing to one of the microgrid is not possible in the centralized arrangement, control arrangement. But decentralized arrangement, the biasing is possible. The transparency of the system is low and transparency will be high in the decentralized case. Reliability will be low and reliability will be high in the decentralized case. Scalability is the low and scalability will be high in the decentralized case. Implementation difficulty is low in the centralized case. Implementation difficulty will be high in the decentralized case. Okay, the control strategies in the EMS. The control strategies in EMS can be taken like this: energy management control strategies into three categories: optimization based, learning based, and rule based. In traditional one, the rule based one, deterministic rules will be there for controlling the frequency or load following. Then Boolean logic will be there and fuzzy logic. The advanced one is. Then the learning based will be involving with the machine learning related approaches, that is black box based development of machine learning algorithms for the better learning and control. Then the third one is optimization based. It can be an offline optimization or online optimization. Offline optimizations, you can use many offline optimization algorithms to schedule it, to properly find the economical operations. Or online optimization means in real time we can run the optimization algorithms to provide a better optimum operating point of the systems. Okay, let's move on to the case studies of implementing energy management system for EV charging stations. Here I'm going to compare two methods. The one is the traditional state flow based implementations for EMS, energy management system implementations. Another one is like artificial neural network based energy management system implementations. The system considered here is the EV charging station, electric vehicle charging station, which consists of a PV installed in the charging station itself, which is connected to the DC bus bar through DC-DC boost converter, and we have grid that is connected to AC-DC converter to the DC bus bar. Then we have EV, electric vehicle, can be connected to DC-DC buck converter or charging station battery. The charging station has a energy storage element, which is known as charging station battery, and parking lot vehicle, PLV, parking lot vehicles. So mainly we focus on supplying to the EV, who is always taking power from the EV charging stations for charging their EV battery. Apart from the PV generations, the grid will also support the load requirements, right? EV also supports the load requirements. Then these two components supporting the energy need by the EV. Apart from this, the charging station batteries also either support charging and discharging can be done depending upon the EV need. Then parking lot vehicle also can support to the EV charging. When the grid is not available or PV availability is very low, then we can support, we can get the support from PLV, parking lot vehicle. So additional support here available is charging station battery and parking lot vehicle. So these two are going to provide us additional support apart from the traditional grid support of EV charging stations, as well as the um, so apart from PV and grid support for the EV users load demand, we have charging station battery and we have the parking lot vehicles. This is the configurations considered. Okay, let me quickly go with the state flow based energy management systems. There are 19 states implemented based on these parameters. That is, identify the operating mode. If grid is connected, say yes or no, then what is the status of charging station battery and PV and SOC of EV? Based on that, these four parameters, we will have 19 different states of operations. For example, state 1, EV is not charged. Then grid charges the EV, like that. For example, we'll go with if grid is connected, yes, charging station battery is available, it is supplying. No, PPV is greater than 0, so no PV supply is there. Then SOC of E is EV vehicle of SOC is greater than the optimal value, then EV is not charging. If the SOC of electric vehicle is less than the optimum value required, then EV will charge through grid supply, because PV is not there and uh, the charging station battery is also not ready to supply. If PV is available, then both PV and grid will supply, right? Both PV and grid will supply. Like that, 19 different states are established in both grid connected mode and both grid connected mode, as well as this is grid connected mode. This entire thing is like grid is there. Then this state 11 to 19 discusses or defines the standalone mode of operation. Grid is not available. So state 1 to 10 grid is available, state 11 to 19 the grid is not available. Okay. So how to implement this state flow based EMS in the simulation software? This is the okay. So the state flow based EMS implementation in the MATLAB software environment is implemented with all the 19 states based on the conditions which we discussed in the earlier slide. So for example, it is a grid connected mode. So mode 1, like that, state 1, something like that, state 1, state 2, like that, it will move on up to state 19. So all the states will be defined like this. This is for energy management systems control depending upon the 4 different parameters. That is, grid is available, PV is available, charging station battery availability, then the SOC of the EV. So based on that, we will decide what's supposed to be the state of the systems, current operating state of the systems based on the 4 variables. Now, I will show you the comparison results. So once we implement this state flow based energy management system for electric vehicle charging stations, and now I'm going to explain a little bit on ANN based energy management system implementations for the same configurations of EV charging stations. This brings the realistic energy management strategy design, which employs real-time data is processed. The model using ANN directs the EMS to carry out the I'm sorry, someone is using the annotations. I'm not using it. Others are controlling it actually. Please stop annotating on the screen, please. I don't want to mention the name who is annotating. Let me erase this. Okay. So the model directs the EMS to carry out necessary switching operations needed to allocate the resources in the electric vehicle charging stations with fast response. This method of implementing the ANN brings the advantage. It is easy to implement and it is flexible to incorporate further modifications in the future. Although ANN has been employed earlier for various applications, but the EMS for decision making as the ANN implemented as a decision making algorithm in EMS for PV powered EVCS with the CSP, charging station battery, parking lot vehicles with multiple scenarios is novel. And to make the EV charging more green and PV based EV charging station is taken for designing the strategy. And we need the charging station battery because the PV is not available always. It is available only during the daytime. So that makes the charging station battery availability to reduce the operating cost of the systems. And the CFB, the charging station battery, is also included in the model to compensate the intermittent nature of the PV. Please, Rocky, please disable your annotations options from your screen. Please don't write anything on the screen. Okay. So the PLV, parking lot vehicles, are the EVs that are available as ideal resources at the parking lot, so which can go for V2G and G2V operations. Then efficiently managing energy from multiple sources in the EV charging station is a complex task. So the implementation of EMS using ANN algorithm is shown in this flowchart. So we will read the values of PV availability, what is the charging station battery PLV, and the users electric vehicles SOC level, and time of unit pricings. All those things we can read it, and based on that we run the ANN model, which is trained already to predict the state of the systems. The predicted state will be given to the energy management systems, which allocate or which implement the switching actions to allocate the resources corresponding to each state. So what it will do is actually, what it will do is the ANN, pre-trained ANN, will take the decisions of or predicting the state of the systems to be operated. Then that predicted state of the system will be given to energy management systems, where the energy management systems will either cut off the grid or cut off the PV or cut off or switch on the charging station battery or parking lot vehicles. So it manages the switching status of all these four important components based on the decision taken or predictions obtained from the ANN. Hence, the ANN-based EMS for a PV-based EV charging station, it gives that input variables are state of charge of the EV battery, mode of operation, grid connected or standalone, available PV power, time of use tariff, then SOC of charging station battery, SOC of PLV. Based on these input variables, the ANN decides what is the mode of operations to be decided, so that it will give, and based on that mode of operation, energy management system will take real-time decisions to on or off the switches at different levels or resources or loads. So here the grid connected mode will have 15 combinations, and then standalone mode will lead to 2 combinations. Based on that, the different resources and load availability, we will have total 79 different scenarios. It's not same as 19, which we have implemented in the uh, you know state flow based method. Here, I denote here this as scenarios. There are 79 different scenarios are possible. All the scenarios are like carefully counted in or considered in the systems. While implementing, all the scenarios are 79 scenarios are considered carefully. So we have 79 unique scenarios, with each scenario tested multiple times with random input variables within the possible limits. It's not completely random. What is the possible limits of input variables to that adheres to the scenarios criteria? Then with the accuracy of training and testing, so we have maximum accuracy of 98.9%, which was obtained for the scenario number 50, and minimum is 91.2% obtained for scenario number 55. So these are all the various combinations of ANN implementations, the various functions taken in the various layers, and then the below one is what is the training functions used and what is the maximum efficiency achieved during the training, the accuracy achieved during the training. 98.31% accuracy achieved through Bayesian regularizations training functions. And this shows for all 79 scenarios, this shows that all 79 scenarios, what is the predictions accuracy percentage, right? Prediction accuracy percentage is shown here, and percentage of total scenarios versus prediction accuracy, that is shown here. Prediction accuracy, almost all the scenarios are having accuracy above 91%. This is a histogram. So above 91%, almost all the scenarios are having accuracy. For example, above 95% accuracy, so more than 50% of scenarios are having above 95% accuracy. So through this accuracy mapping of all the scenarios, whatever we have obtained, when we implement the energy management systems through state flow based algorithms or through the ANN based algorithms. So when for in this example, if you look into this example, the grid active power is 0, and when the grid is connected, so it is changed to like this when the grid is connected. So state labels, it is from 13 to the actual expected transition is to the scenario number 5. Here the dotted red color line, it is expected. But in the state flow based implementation, it will go to the state of 8 for some durations, and then it will transfer to state 5. Instead of directly going or moving to state of 13 to 5 directly, it will be going through intermediate states in the traditional state flow based implementation. Whereas in the ANN based implementation, the state level will reaches almost immediately, right? Both are having same changes, the load changes, grid active power changes are same in both the cases. Around nearly 0.5 or 0.6 is the power changes occurred in both the cases. The right hand side shows the state label, or it is changing directly to 5 from 13. So that is the advantage. Immediate response is possible because the traditional state flow based method, it will go through different operating states in between available, and then it will move on to the finally settle down into the actual state. So everything is carefully analyzed, and this is one example for implementing the machine learning based algorithm for energy management systems in the electric vehicle charging stations. So the performance of the ANN based EMS is validated and tested for multiple cases. Upon analyzing the test result, it is evident that the system is highly effective in reducing the overall operational cost. So when we have such kind of operations over a period of time, so this is multiple period of time without EMS and with EMS, when we implement it, the power supplied on the various components are given here: PV grid, charging station battery, and electric vehicle. The load is given, and that is the black color in the bottom. Without EMS in the left hand side figure, with EMS. So how much variations or cost is there? There will be a 28% reductions in energy consumption when ANN based EMS is implemented over a period of 24-hour simulations. Okay, this is the case study 1. Sorry. Okay. The case studies 2. What is the issues in the electric vehicle wireless charging systems? Is most challenging one is the misalignment of the charging coils. It may not be accurately placed. The electric vehicle may not be accurately parked above the transmitter coil, so that power transfer is not efficient in such cases. So misalignment causes the biggest challenge in the wireless charging systems, electric vehicle charging systems. So how to avoid this? Manual adjustments of the coil is actually slow, inconsistent, and impractical for large scale use. And the lack of automated alignment prevents real-time corrections, making wireless chargings unreliable. So how to avoid this? So it's the right hand side is like a prototype which is developed in one of our lab through the group of students for misalignment corrections, detections, and corrections using AI based systems. So the students developed in this case to find the misalignments. So the parking platform is like a transparent platform which is shown here. This sheet is the transparent sheet is there on the top. Above that, the electric vehicle is parked. Right, electric vehicle is parked here, and below that, the charging coil is here. The charging transmitter coil is here, and in the bottom here, just below this location, there will be a receiver coil in the electric vehicles. Now, once the user is parked the vehicle, the system has to align the transmitter coil just below this receiver coil. For that, the system developed has camera, high quality camera connected to the base of the moving platform in the transmitter coil side or charging station side. So what it will do is it will scan the entire platform area after the identifying the vehicle is parked. It will scan through camera and identify where is the receiver coil of the electric vehicles parked, and identify what is the XY distance in the horizontal manner, horizontal framework. Then the distance sensors available here will try to identify what is the distance of the coil from the charging platform or this platform, the horizontal framework, then the vertical movement is also there. So in this way, all the three dimensions are covered in this case. So the camera will identify the horizontal XY directions of the transmitter coil from the receiver coil. Then the distance sensors will identify what is the Z axis vertical distance to be adjusted. So the entire thing is implemented, or control algorithms or identifications, misalignment detections and corrections, everything is implemented in Raspberry Pi platform for automatic misalignment corrections. Okay. So what is implemented in the Raspberry Pi based coil alignment systems? The OpenCV code, which is detecting the circle of the receiver coil and what is the center. How much distance is there from the transmitter coil to the receiver coil in the XY distance, XY directions, and also detects what is the Z directions to be operated from the servo motor to align the vertical distance, the Z axis. So XY distance is measured by the camera. So vision based deductions of the distance detection of the transmitter and receiver coil, and the vertical distance Z axis will be detected from the distance based sensors. So as you can see here, the implemented algorithms in the Raspberry Pi board, and the motors are there for X and Y axis, and servo motor is there for the vertical Z axis movement. So this is actually the transmitter coil of the charging stations. And if you see this, the vision, the camera detecting the receiver coil of the electric vehicle. So the vision based algorithm which is trying to detect the circles and where is the center and how much the distance should be moved. And there is, for better visibility, there is an LED also connected to the moving platform of the charging stations, so that the coil location can be exactly detected. So LED is on. So what is the servo motor location? So X, Y, Z, all the directions are detected using this camera based, vision based detections, as well as the distance based sensors detections. So this shows that the wireless charging systems misalignments, how far the both the coils, the transmitter coils and receiver coils, how far it is away from each other. Those things can be detected easily. Once it is detected, then the automatic alignment will happen. Automatically the XY direction will change, then finally Z axis will, the movement in the Z axis will be there. So it's a lengthy video. So let me play this video to show you quickly the portion of these things. I will let me show this. I hope the sound is also visible. System sound is also visible. I'll just move on. So the implementation aspects, the components. So I will just show you it's automatically aligned. Now its charging is happening in a much effective way. So it's coming back to the initial positions, resetting it once charging is over. Once again, I will show you the LED is on, camera is trying to detect it, and alignment is happening. right? So that is the automatic alignment detections and corrections of EV wireless charging systems. So what is the conclusions? The climate changes happening because of the enormous usage of fossil fuels to be mitigated through the effective measures as given by the various international standards or the government policies. So we have to go for sustainable solutions. Then AI based EMS is very crucial for efficient EV infrastructures. And the ANN models, it enhances the real-time control and energy optimizations. Future advancements in vehicle-to-grid, IoT, and machine learnings will further revolutionize the EV charging infrastructures, and it will be very much convenient. The same students group is now working for digital twin for the wireless EV charging stations. So a lot of advancements are happening, and they are able to successfully implement the digital twin operations for the electric vehicle charging stations for wireless systems, wireless charging systems. So these are all the references of some of the references which is useful and referred for this lecture. I thank you for your listening. Thank you all.
Thank you, sir. Thank you so much.
Thank you, Professor Ravi Kumar Pandey, for your wonderful session for last 1 hour 15 minutes. Really, it is an eye-opening session on EV vehicle. Participants, if you have any queries, questions, you can share it in chat box. Another 5 minutes will be allotted for question answer session.
Can we answer to the mic? Can we ask questions to the mic?
Yeah, please.
Sir, I have a question. Is wireless EV charging failure, or it can be improved as technologies improve?
Yeah, it is not a failure system, sir. There are a lot of systems available already based on the wireless charging. For examples, during my postdoc in Masdar Institute of Science and Technology in Abu Dhabi, right now it is renamed as Khalifa University. If you search for Khalifa University Masdar campus, now you can find it. The system is called PRT, Public Rapid Transportation Systems. So there are two stations. One is from the at the entrance of the city, Masdar city. Another one is in the institute side. So there are 6 parking lots. When the vehicle comes and parked over there, it is automated systems, no driver, nothing is there. It's the EV vehicle is automated EV vehicle. It takes the defined path, already predefined path. It will move from one station to another stations, which can carry 4 passengers. So if you take such kind of systems, the wireless charging is there. Once it is parked in the parking lot, before picking up the people or in between, so it will automatically charge. Since the system is known, or the same type of unique type of EV is used, even automated EV is used, and it is centrally controlled and monitored properly. I'm talking about these systems from 2011 onwards. It is function. 2011, it is functioning. The system is there. Automated driverless system, public rapid transport systems is available, which has a touch screen, emergency call, and all those things are available in that systems. But if we are taking about the public charging stations, where different type of electric vehicles can come for wireless charging, if it is wireless charging options are available, the difficulty is depending upon the vehicle's dimensions, the charging coil misalignment can happen, which is unavoidable. We cannot say that in the public charging stations The wireless vehicle, like it is like all unique type of or manufactured vehicles can only come. We cannot define that. So multiple vehicles can come. So depending upon the height or the dimensions of the systems, it should go for it should detect the coils locations and go for charging. So for
Uh,
that, the misalignment is most important things to be challenging thing to be detected. It is not a failure one. It is challenging one. We cannot say that it is failure. It can be corrected if proper system or technological development happens, right? Uh,
yeah.
a long time back, smart grid is a failure, we will say. Now the technological advancements and the data is a fast communication system layer is available. Now smart grid is like implementable. In that way, so we need to advance our systems and a lot of findings should be there. That's why I told you, digital twin. The one word I told you, our
Yes, sir.
students are working on the digital twin. That is realistically you can visualize it. What is happening in the real time? How the system misalignment is happening, how it is detected, whether it is properly aligned and then charging is effectively happening or not. It is like IoT and user interface and modeling. All those three items are combined as a digital twin. So with that, we can go for successful implementation of wireless charging stations for the EV
ಅಣ್ಣ
vehicles.
ಸರ್ ಅದಲ್ಲೇ ಜಾಸ್ತಿ ಟೈಮ್ ಹಿಡ್ಕೊಳ್ಳಲ್ಲ ಇಲ್ ಟೇಕ್ ಲಾಟ್ ಆಫ್ ಟೈಮ್ ಟು
Hmm.
charge because wireless takes a little longer time to charge as compared to putting the socket directly to the car because earthing issues and all will not happen and
Yeah,
time duration.
yes. Definitely, there will be a disadvantage with the wired one and wireless one compared to wired one. Wired one, it's directly connected and magnetically locked, and it is going to charge with more efficient systems. But wireless will have some transfer efficiency. So these misalignment systems or corrections will uh, avoid such efficiency, lowering the efficiency. It will try to improve the efficiency. So we measured through our basic system setup what is the maximum efficiency which can be brought back if the misalignment is corrected effectively. So it is going to give us 50% efficiency from the coil to the other side. So, but this helps. Suppose you use a mobile phone, for example, you use mobile phone and when you are charging it, and
Sir.
when you are using the wireless charging of your mobile phone, still
Yes, massive.
you are
Yeah.
using it, right?
Yeah.
So what is the capacity? If this is happening with 45 watts charging capacity, if you're using same mobile phone with wireless charging, it may go up to 18 watts or 20 watts. Why that
20
is
is
there?
max. Yes,
Yeah,
sir.
the maximum wireless is like less
Yes.
efficient. It will take a lot of time to charge, definitely. But some users prefer this and they don't have the socket to charge or the configurations to charge, right? Adapter is not there to charge in the wired connections. Then this wireless will be effective for them. Not only that, not only such kind of things, the wireless can be taken in a different manner. India now, recent news, last week news, I hope you might have read the news. PV panels are installed in between the railway tracks.
Yeah. I was coming to that point only.
Yeah,
Yeah.
5 kilometers.
Yes.
What is that usage of keeping 5 kilometers length as a testing phase of PV installed on the railway track? There will be a lot of vibrations, a lot of, so you can say that after testing only we can say that it's a success or failure, right? The
Yeah, but
vibrations may causes lot of cracks or maybe panels efficiency losses, all those things may happen, right? So
yeah.
once we get yes,
Momentum
please
also
go ahead.
will play a role.
Yeah,
Yeah.
yeah. And when the train is moving above the track, then it is covered, it is shaded, no generation will be there all of a sudden. So it is
Yes.
generating, then the stability issue will be there. It is not continuously giving the power. The shading will happen immediately as soon as the vehicle is moving, the train is moving above that,
Correct.
right? So, but Indian government wanted to, railway systems wanted to test it, how far it is successful. We have to wait after taking the lot of data, and we have to analyze the data, right? And based on the data analytical things only, so whether this is can be implemented in the bulk project or not. Right now it is implemented in the pilot phase. So such kind of things are going on, with a lot of things are going on. So once we say that it is successfully the technology is developed, then we can go for full implementations. Definitely the things will change. The system will model will change.
Improvise, yeah.
Improvise over the
Yes,
period
sir.
of time. But we need to
Thanks,
move on.
sir. Yes, sir.
Thank you.
Yes, sir. Thank you so much, sir. Thank you.
Thank you.
Any other questions? If no other questions, shall we wind up the session? Mr. Ravi Kumar sir, please stop sharing your screen so that we can take virtual group photo with all the participants.
Sure. I stopped the.
I request all the participants to switch on your camera. Thank you so much. Next session will start in another 5 minutes time. We are waiting for the speaker to join. So meantime, you can take a small tea break.
Thank you.
It's not a virtual break. You can take a physical break.
Thank you, sir.
Thank you.
Yeah, good evening. This is Dr. Ramarao. Is there any organizer?
Yeah, thank you, Professor. Thank you, Professor.
Yeah,
Nice
yeah.
to meet you,
Yes.
host.
Yeah, I'm back. Just
Yeah.
now I have completed the
Yeah,
another meeting.
I have given participants to take 5 minutes break.
Yeah, sure.
So we'll start the session by 7:25.
Oh, nice. Okay.
நீங்க அப்படியே சொல்லிருக்கலாம். ஓகே சார், ஓகே சார். இப்படிதான் சார் ஸ்டூடெண்ட்ஸ் மாதிரியே பிஹேவ் பண்றாங்க. So anyway, thank you sir. Thank you so much sir. Thank you. எல்லாமே ஷேர் பண்றேன் சார்.
Sir, I have given you the co-host privilege. Now you can share your screen.
Yeah, done. Yes. Is it sharing? No. Is it sharing?
Yes, sir. Yes, sir.
Yeah.
You can go for slideshow.
Yeah, sure. We'll make it. Hope it is visible now.
Yeah.
I think the title is AI integration, right? Of our
Yes, sir.
FDP.
Yes,
Yes.
sir. Yes. Participants, shall we start the session? Now time is 7:26. Before moving on to the session, let me give a brief introduction about the speaker of the next session. I heartily welcome Dr. P.V.V. Ramarao, Professor and Head, MBSR Engineering College. Sir has very vast experience in teaching as well as in industry. He is serving in different positions like lecturer to principal. He has taken up all the leadership position, head of the department, dean, and other portfolios. And he has published more than 48 papers in reputed journals and conferences. He has published 2 books and awarded 2 research scholars with PhD. And he has received 3 crores external funds for various projects from the government of India. He's having 4 patents in his credit, and he has obtained many NPTEL certificates and other recognition from the reputed organization. Sir has organized many workshops, FTP conferences, and he has acted as a resource person in so many other sessions. I am very happy and privileged to welcome the resource person of the session, Dr. P.V.V. Ramarao. Sir, thank you, sir, for accepting our invitation.
Yes.
Please take over the session.
Yeah, hope I am audible.
Yeah, perfectly, sir.
Yeah, thank you for our welcome, sir, and a hearty welcome for all the participants for this 1 week Atal Fdp. And coming to the electric vehicles and charging networks, and coming to the theme of our title of the FDP, there is AI integration of renewable energy sources, something like that, for electric vehicle charging networks. And before going to see that, actually what is charging station or AI integration, what it can do. Before that, maybe this is what actually going to give you the context, or what you call the elaboration, or maybe a knowledge. Okay, what this smart means for vehicles, because nowadays everybody wants smart, and every system should be embedded with the smartness, something like that. Smart systems, nowadays we are talking more about smart systems, and the other side, of course, smart staff or smart students, like that. Maybe everything is smart, going to be smart with smart systems, smart students, and smart staff. Okay, so maybe smart systems are going to replace the conventional systems very soon. Of course, already slowly replacing, and disruption is taking place in the technology. So technology disruption. Then, of course, smart. If you come across the smart, I don't know how many of you come across the the language or the word smart, and how many of you referred the dictionaries for the word. Okay, the meaning of smart. Okay, of course, in variety of context. Just now I used the context smart. Okay, for the systems, context of systems, or context of education, context of teaching learning, like that, in variety of contexts. Smart. Hope I am audible. Anybody, please respond. Any,
Yes, Professor.
yeah. Thank you.
Very well audible.
Yes. So, of course, different aspects of uses. That is what smart. And see, everyone has have their own what you call understanding, or the uses, like from the different perspectives. The smart. But when it comes to the technology, that's what actually, how smart the gadget, or how smart the system, how smart the technology, how user friendly this technology, or how uh, uh, wide, what we call multiple or multi applications, something like that, application point of view. Maybe when it comes to the technology, that's what we can say, that smartness, or okay, how fast and how accurate and how reliable. Okay, that's all we can take up, okay, from the technology perspective or technology aspect. And when it comes to, I think, hope most of you are electrical or mechanical engineers. Okay, the participants are students or scholars. That's what. Okay, we are all well versed with smartphones, smartwatch, smart TV, smart meter, smart grid, smart mobility. Last three may be more closely related to our electrical engineering or energy engineers and power engineers. Smart meter, smart grid, smart mobility. And maybe that's what actually, and the other way around, we can take this Atal FDP entire theme, maybe like smart mobility, right? Integration of AI and renewable energy sources into electric mobility or charging networks. That's what. And when it comes to the smart, this is what actually, maybe one can understand, that intelligent, clever, wise, brilliant, sharp, user friendly. Actually, I have to ask the question, right, the participants, but anyway, I am giving the answer. That's why it is given that tick mark, whatever you call it as. Nowadays, the smartness means more user friendly. Okay, if it is user friendly, if it is more and more user friendly, then it is more and more smart, something like that. The technology can be called as, or treated as, more and more smart. And what this smartness, that's what IoT. Okay, maybe, okay, utilizing the IoT, internet of technology, internet of things. Okay, nowadays, of course, we are calling it as internet of everything, or what we call everywhere internet, and everything is internet, something like that. IoT. Okay, IoE, internet of everything. Okay, uh, maybe internet of tons, something like that, right, we can call it as. Then AI, artificial intelligence, nanotechnology, then soft computing. Hope you are okay, very well, okay, familiar with all these emerging technologies. So if you add, okay, if you integrate, if you just embed, okay, these emerging technologies into our systems, the conventional systems or semi-conventional system or semi-automatic systems to make it more automatic or fully automatic, something like that, then you can say, okay, the system becomes smarter and smarter. Okay, one day or the other day, okay, so maybe smarter systems are going to play a wide role or major role in the society. That's what smart society. Maybe it becomes smart society, right? That's what here, of course, connecting humans, relations, society, then communicating humans, phones, social. Okay, this is what all these types of systems connecting, communicating, connecting, communicating, collaborating, creating, performing. Okay, all these things. See, when it comes to only connecting humans, relations, maybe it is called society. And when it is coming to the communicating, when it comes to the communicating humans, that's what phones technology and socially moving, something like that. And connecting and communicating humans, that is what internet. Okay, that is the technology. And because of that, this actually globalization is rapidly, okay, adopting, the entire world is adopting rapidly the globalization, something like that. Of course, globalization, digitalization, right? Globalization maybe because of internet or this ubiquitous network technologies, Wi-Fi and all, and digitalization because of these smart systems and all. So when it comes to the performing user friendly, that's what IoT, AML, and all these emerging technologies play a wide role. When it comes to the smart systems and flow, of course, these are not my own okay images, and here it is given that, okay, reference links and all, right? So the smart systems, right? And maybe when it comes to the smart systems, okay, what they are meant for and what is the flow of smart systems. Okay, if you look at, okay, these two images, one can understand, okay, smart systems and their flow, right? Smart flow, that's what. So here, I just know I told you in the previous slide, ubiquitous internet and ubiquitous network, which cannot be replaced with conventional systems, and conventional systems are on the other side being replaced with internet and all. Okay, so this is what actually here going to take place. Okay, and through this ubiquitous network connecting with physical and information systems, that is cyber physical systems nowadays we are calling on the other side. Okay, cyber physical systems, cyberspace and physical space, if you integrate with the help of this okay, sensors, ubiquitous internet or IoT and AML, okay, technologies, emerging technologies, then it becomes smart systems, right? And here, that's what, okay, integrating into, maybe embedding intelligence, embedded intelligence. Nowadays I talk, okay, usually I okay, wherever I give the talk, okay, somewhere I heard that embed the intelligence in the systems or integrate the intelligence, okay, in the systems, that is going to innovate the things. And that is what in devices and systems with technologies, if you incorporate intelligence, then integrated devices with interconnected applications offer n number of wide variety of, okay, capabilities, that is unique capabilities also, like unique capabilities you can obtain or one can achieve, right, with the help of this integration of intelligence or intelligent devices. Okay, and here, combining data processing with multimodal, we can say that optical, biological, mechanical, is all combining all this multimodal, okay, processing, sensing, actuation and communication functions, then you can get it miniaturized smart system, something like that. Then what do you mean by integrated smart system? See, before going to see that the application of smartness, smart mobility, or the smart for mobility, let us see what is actually smart and what are the various type of various technologies helpful for making our systems smarter, smarter and smarter or more smarter. Okay, that's what actually here. And when it comes to the integrated smart systems, we will upgrade the capabilities, that's what, with the multimodal approach and combining various systems like optical, biological, mechanical, even electrical, okay, sensors and all existing hardware by IoT or AML or, okay, tackling big data interpretation. That's one. And enable augmented or enhanced decisions. Okay, maybe just on their own independently or collaboratively, right? That is also possible. Okay, enhanced decisions or decision making will be more effective, right, with the help of this integration of the smartness or integrated smart, okay, intelligence, integrated intelligence. And this is what actually our real story, that is smart mobility. So far we have seen what is smart. I think I did not spend much time, only just 5 to couple of minutes I spent on smart. And of course we are all very well familiar and very much familiar with this word smart, because nowadays everybody, especially the our colleagues or our friends, okay, usually say that, oh, you are so smart, you are okay, you are different. Okay, smart may be different, right, nowadays. That smartness, right, people are talking. And when it comes to the smart mobility, that okay, mobility as a service, of course we have to look at. Mobility is especially a service sector. And when it comes to the smart mobility, okay, combining, okay, all these like electric mobility, shared transport, autonomous vehicles, then intelligent transport systems, demand responsive transport, all these together is mobility as a service. And maybe a couple of things are interconnect to or something like that, or interoperable, something like that. And here shared transport, electric mobility, maybe free floating e-mobility. And then shared transport and autonomous vehicles together, maybe you can name shared autonomous vehicles, like that. Okay, so the intersection part, right, you can name like this. And when it comes to the intelligent transport and autonomous vehicles, maybe connected autonomous vehicles, connected because intelligent. So that's what connection, communication, collaboration, cooperation, okay, and creation, right? So all these c's may work out, okay, may work together under this connected autonomous systems. And when it comes to the demand responsive transport and combining or in coordination with intelligent transport systems, you can call it as flexible transport system. That means overall mobility, if you look at as a service or smart mobility, then you can achieve flexible transport service, you can have free floating e-mobility, you can achieve shared autonomous vehicles, the okay, various models, right, you can have under this smart mobility as a service, right? And when it comes to the left side diagram, my left side, the transportation built on access, not
Sir,
ownership, right? Please
still
keep this. If you
first
keep this
slide is
logo,
showing.
pardon?
Still first slide is showing.
Oh,
There is no
it's not
change.
changing.
Yeah.
No,
Yes. Now it's okay.
is it full view? No,
Not a full view.
full view is not coming.
Mm.
I made it full view. No, it's not coming. Then I'll reshare, right? I'll stop and reshare so that you may get it. Now at least.
Yeah,
Is it?
slides are visible,
But it is not full view, right?
not in full mode.
You are not getting full view. Then what I should
Maybe
set up
you
slides
can
now?
press F5.
F5. Okay. Yeah, I did. Is it?
No,
Is it visible? Full slide? Full
no,
view?
no.
No.
Mm.
Oh. Now at least
No, professor, no change.
no change. Okay. Then I'll close and then I'll okay. I'll stop sharing and then I'll come back. So now I think I stopped sharing. Is it stopped?
Yeah, yes.
Yes. Okay. window sensors. Oh, please check it. Is it sharing?
Lights are visible, but not in full view.
Oh, I don't know why it is.
No problem, no problem. You can proceed.
Yeah, oh, yeah. Here I am getting, actually on my screen I am getting full view. I don't know. Okay, right. So that's what actually. So this mobility as a service, maybe you can call it as mass. Okay, mobility as a service. Okay, which provides a platform that treats transportation as a customizable on-demand service with a la carte mobility, real-time travel information. Nowadays, we are seeing that this Wala, Uber, all these things are adopting this kind of mobility as a service, and they are doing business on this revenue model. On this business model, they are operating this mobility. Of course, uh, they have not added electric mobility and all. And nowadays, maybe I think in future or very soon we are going to see that electric mobility also and autonomous vehicles also in their business. So, micro transit and commuter circulators, public transit, bike shares, transportation network companies, all together, right? As a mobility as a service, they operate. That's what maybe you can call it as. On the other side, is also a smart mobility, and here there is another way of understanding the smart mobility with maybe a simple image. And here, see that the connecting, connections, see the dots, the connections, you can see that how the connections will make the system smarter and smart. So connecting and communicating is very much important and very basic uh, parameters, right? You can understand in the smart mobility, connecting, communicating is very much important, and it is very basic, of course. So technology to provide better connected mobility options to people and goods to go wherever they need, regardless of their transportation option. Okay, maybe called as smart mobility is what transportation network. Here, see that the transportation network companies and electric vehicles, autonomous vehicles, shared transportation, bikes, etc., bike sharing, car sharing. Then even nowadays, these things will also very soon enter. Of course, already started drone delivery, drone technology. Then coordinated plus priority signals. That's what based on this. And community mobility hubs, and all data management services all together, we can say that smart mobility, right? And what do you mean by smart vehicle or smart mobility? Of course, when it comes to the smart mobility, vehicles should be equipped with smart systems or smart technologies must be integrated into the vehicle, conventional vehicle or electric vehicle, whatever it is, or hybrid electric vehicle. And the vehicle user gets the needed service because of this integration of the smartness or smart systems, or because of the adoption of the smart sensors and all. And so to make the vehicle smart, actually, whatever we are calling it as IoT or AI. Okay, so building vehicle as per end user needs or consumer needs or the vehicle user needs, right? Uh, uh, that's what actually use of onboard computers, sensors, and controllers, actuators. Okay, makes up a smart vehicle more and more smart, led to many of the advancements and many of the features. I don't know how many of you are familiar that ADAS. Okay, I think of course people are using nowadays ADAS. Okay, what is that? Anybody? Any participant? What do you mean by ADAS? Anybody using this type of cars or four wheelers? ADAS systems. Anybody, please? Am I audible?
Yes, Professor.
Yeah, yes. ADAS, I don't know how many of you heard, but nowadays actually high-end cars and all, like especially MG and all, okay, you are going to see that this ADAS, okay, adopted vehicles, and so advanced driver assistance systems. That's what actually really revolutionizing the vehicle safety in India, especially in our countries. That is going to provide more and more safety to the vehicle users. These ADAS systems, because see, we are all human beings, and manual driving and all. Sometimes what happens, we are all facing. Of course, suddenly something may come to our mind, and we may forget something to, okay, apply brake or something like that. Okay, and because of that, safety is questionable, and because of this advanced driver assistance systems, right, maybe, okay, the vehicle is more safe, okay, and the end user is more safe, and of course commuters will also be safe. That's what actually. And here, maybe that advanced driver assistance is going to keep, right, the vehicle as per the destination set, or as per the route given, or as per the map, okay, and as per the real time road condition or traffic condition or traffic congestion, right, it is going to take care all those things. That's why it may be somewhat safe, okay, compared to the manual systems. That is what actually smart, right. So replacing the manual intervention with one way or the other way of, okay, technology, one or the other kind of technology, advanced technology, uh, will make more safe also, safety also, okay, increase that, not only reliability or cost, okay, it will also increase the safetyness. And of course, I told you already what is smart and what is definition. So, vehicle that utilizes internet connection to an external system in order to optimize performance or operation or mileage or whatever it is. Okay, you can call it as smart vehicle, and can be applied to any vehicle, even a conventional vehicle also you can apply, or okay, ELUs or hybrid electric vehicles. It's not limited to only autonomous vehicles. That's what smart technology can be applied to any type of vehicle, and vehicles are now producing more power using smaller engines, so all while reducing emissions, carbon emissions and all. So a commercial van that utilizes an onboard telematic system to track real-time location and driver behavior, okay, is going to reduce the emissions, and on the other side, okay, what you call better utilization. That's what actually, okay, is good. And coming to the architecture, that's what here it comes the AI, and of course renewable energy. Later you can utilize the renewable energy for powering the vehicle, that motor and all, okay, to produce the required propulsion power, okay, that traction, okay, that's what. And here, integrate smart structures, next generation suspension or mounting devices, actuators or valves, intelligent sensors, okay, and then analyze the model, characterize and design innovative engineered components, and all these things, and see, these all going to add, okay, more and more features from the perspective of motion control or diagnosis, self diagnosis. That's what, leading to self diagnostics, okay, if any vehicle breakdowns and all, or maintenance requirements, everything will become self diagnostic kind of thing in the smart vehicle architecture, and sensing, self healing also. Maybe that smartness introduces, or smartness strives for self diagnostic, sensing, self healing capabilities, while satisfying the increasingly stringent vehicle design requirements. That is also, this is what smart vehicle architecture. Actually, it is a trademark given by Aptiv, this one organization. Of course, I got it, the reference from the Aptiv. What is the smart vehicle architecture, right? You can see that the smart vehicle mainly composed of these three, okay, constraints, are the components: power data center, unified power and data backbone, and then central compute cluster and all. What is power data center? PDC, universal docking station and zone consolidated. Just now, before coming to this session as a resource, I am just in the other meeting like MSME Idea Hackathon. They are talking about unmanned advanced drone docking system, something like that. It is also one kind of universal docking station. They proposed under this MSME Idea Hackathon file. It is also okay getting wider interest okay among the what you call entrepreneurs and technologists. Docking stations, docking systems, docking stations, universal docking station. That's all. And coming to the unified power and data backbone, is of course modular and automatable harness technology, okay, designed for redundant networks via dual ring topology and all. And coming to the triple C, that is Central Compute Center, the universal compute platform with standardized interfaces and connected secure gateway. Okay, and all this is possible because of the okay sensors and actuators, controllers, okay, different central uh, different components. That's all. So here, when it comes to the smart vehicle, like if you want to integrate AI into your vehicle, okay, gesture control, communication, then integration with smartphone, apps and firmware. This is what actually the division, right? Different, what I can say, when you look at architecture, okay, different compartments. What I can say that in smart vehicle systems are different parts, right? You can take it like that also. So gesture control is one aspect, communication control. Communication is a second aspect. Then integration with smartphone, then apps and firmware, right, for the smart vehicle systems. Then further to continue the smart vehicle systems architecture, augmented reality, head-up display, batteries, long-term evaluation. Batteries, that's what battery management system. Actually, before coming to this session, so the organizers requested me to go through even battery management system also. But that is again a big research topic, battery management system. And two of my research scholars, are working on AI-based battery management systems and machine learning algorithms. They are applying for SOC and SOH, that is state of charging and state of health. They are applying machine learning algorithms and for this battery management systems. Okay, if anybody is interested, okay, beyond this session, right, you are always welcome to contact me, and this okay, I can guide you. And coming to the LTE, that's what actually LTE we are going to see in even mobiles also. LTE networks and all long-term evolution here, this one. And self-healing paint and smart fuel saving, that's what SFS and SHP. That's what actually here, okay. And see, adaptive and automotive control is very much important nowadays in smart vehicle systems. uh, and of course the blind spot monitoring, all those things also comes under smart vehicle. And when you come across one on one, that is gesture control first, and it's all okay. Multimedia interface touch enables vehicle user to input characters just by using a finger to write on the, that's what gesture control. Say finger to write on the designated touchpad. Okay, based on that, okay, you can operate your vehicle, which becomes smart. Okay, if you use this gesture control. And nowadays enhanced gesture control technologies are widely adopted, right, in the smart vehicles. And one of the familiar existing technology, that's what you can check here, Audi in 2011 introduced a new feature that would provide unprecedented ease in controlling a car's function. That's what. Like that in 2011 itself, 14 years back in Audi, okay, existing technology of knob and voice controllers, okay, controls RD introduced a new feature. That's all. So communication next, when it comes to the next thing, right, next part, we have to talk about communication in smart vehicle architecture. Of course, like machines communicating with each other, right? Here vehicles communicate with each other, and even vehicle to vehicle communication nowadays, and vehicle to traffic, right, vehicle to user, like that. Again, different portfolios here in the communication protocol, right? So different protocols, different communication okay channels, right? Maybe a day, maybe a requirement nowadays. That's what. And for smoother traffic and less congested roads, right, the communication communicating with each other, okay, That, each other here, each other means vehicle to vehicle, then vehicle to traffic, then what you call vehicle to user, all those, even vehicle to the what you call data center, okay, that PDC, vehicle to PDC, even vehicle to charging network, right? All these things nowadays requirement you can work out. Okay, if anybody is interested, right, in doing research and this communication also, okay, there are many aspects, right? You can look around, okay, in this communication. So appropriate technology implemented will significantly increase road safety, efficiency, and even driving experience. Okay, is also very much important, right? Nowadays, we are getting lot of what you call what I can say, anybody vehicle user, right? So nowadays, hectic traffics and all we are coming across, in the, especially in metros and cities and towns, are afforded driving experience. Maybe mostly most of us are experiencing, right? Afforded driving route or traffic, something like that. And see here, if you look at the recent improvements or advancements in communication, for example, AR, 5G, of course, nowadays.
Excuse me, Professor. There is no change in slide, sir.
Oh God. Oh God. Yeah. Yes.
We are not able to match
I don't
it.
know why it is. Yeah. Now at least.
No.
Yeah, I think I stopped sharing. I'll share again. I don't know why it is suddenly taking like this. Just close it. Is it now?
Yes, sir.
Yeah.
No, it is showing the same manner. So will it change? And now I am having the doubt yet unless you update, sir.
Yeah. Others. Any problem? Any
No,
other
it's
person
not
facing
coming
problem?
to presentation mode,
Yeah. Okay. First of all, the
but
slide
not
is there.
changing
But
also, sir.
I'll change it. I'll change it later. But it's showing the
No,
slide.
now you change and let us.
Communication slide. No, is it visible? Communication slide.
Yeah, it is visible communication now.
Now I changed it to full mode. Is it coming?
No.
I don't know why. I think it is
Sir,
not
in your
allowing.
computer, you have to press F5 key, sir.
Yeah,
In your
even I made
keyboard.
it. Yeah, even I
Yes, sir.
made it. It's not coming. Even I made it. Now F5. Shift F5. It's
No,
not coming.
nothing is changing. No.
No. Yeah, that's what. I don't know why it is limiting or restricting. Even I am trying in the different ways.
Okay, sir,
Slideshow.
no problem, sir. It is visible, but you have to change next slide, sir. Furthermore.
Is it coming? The vehicles with 5G, the first line.
No. No change.
This one diagram, image.
Nothing, sir. Only communication slide is available.
Yes, yes. I think it
Same
will
way.
maybe a slight
Last
delay.
time.
Now,
No.
oh, right.
Yes, sir. You have to move a individual slide.
Now is it coming?
Yeah, communication slide is there with the diagram.
Diagram, yes.
Now it
Okay,
has
anyway,
come
I
that
think it
one.
is
Yeah.
not allowing. Otherwise, I can make it like this. Some image, this one slide. Okay, so I'll make this one increase zoom. I'll make it zoom.
Only changing possibly you may have to go to each slide and click it.
Yes, yes, yes. Each slide I have
Yeah,
to make it.
please. Yeah, that's why. Thank you,
Yeah,
sir.
yes. I don't know why it is not allowing full mode. Uh, I think I have to rejoin. Okay, then only it will come. Anyway, if I rejoin, session will be wasted, right? Time will be wasted. Anyway, I think it is visible and is clear, right? Vehicles with 5G. That's what. And also, this is what actually ITSP, Internet Telephony service provider can be connected to the cloud environment, so that we can make more communicative and communicate with each other. That's what vehicle manufacturers cloud systems, VMCS. And this is what actually nowadays the vendors, vehicle manufacturers are following, and even replacing the existing 4G with 5G, and even an upcoming satellite network established vehicle to the cloud connectivity. That's what, and maybe called as vehicle manufacturers cloud systems. Okay, functionality is based on the network bandwidth and connectivity. That is very much important. And if you go to remote places, maybe okay, the network bandwidth and connectivity issues arise. But still, I think in main areas and all, right, we'll have proper communication and best communication between the like machines, okay, between vehicles and vehicle and user, even vehicle and manufacturer, and vehicle and service provider. Okay, you can maintain. And 5G is high bandwidth and low latency. That's why. And because of this communication protocol or internet, what you call the internet telephony service provider and all service spaces, you can have the exchange of data between vehicles in real time, or vehicle between vehicle and user, between vehicle and charging network, like that. Okay, exchange of data will be better through this communicative technology or communication. And of course, vehicle and its subsystems data could be treated as system data, and data collected from users based on interactions or whatever, for example, source, destination, travel history. Okay. Is it changing slides? Because I am using only the.
Now it's
Yes.
okay.
Yeah, yes, yes. Okay, that's what actually satellite vehicle manufacturing clouds storage or cloud server is different from Apple's CarPlay. And like the different vehicles have got their own manufacturers cloud servers, and smart vehicle systems should be able to communicate with the VMCS system with or without mobile phone. Then only this purpose will be served. And here the smart vehicle can request a response from okay that vehicle manufacturers server cloud system are way. Okay, so like this is what actually one can understand how the communication request and communication service takes place, or the updates takes place. Okay, from this diagram one can understand. Okay, like how the updations also push software updates that are necessary to the smart vehicle system, along with proactive notifications, and even in transit data, secured collected data from system user request or whatever. Then it has to reach, okay, here vehicle manufacturer's cloud system, and then you have to get a response. So upon the requested data, and then that solves, okay, the uh, communication, and that solves the problem, or that solves. This is from NASCOM actually. I got the image from the NASCOM topic, one of the white paper, something like. So that's what. So here, this is what communication. Okay, connections, communications, collaborations. So at any point of time, owner can ask for any help of information or information about a request that he is looking for, or she is looking for. Not all owners are aware of all the features. That's why. Okay, of course, nowadays people are getting educated on the smart vehicle use cases for the communication, for the gesture control, how to utilize the gesture control. Okay, and several use cases can be built to make the smart vehicle system user friendly, or one to owner or end user, how to use a feature, how to do basic troubleshooting, customer support representatives, remote assistance, on-site subject matter expert assistance, SMEs, subject matter expert assistance, and smart vehicle object sensors for school buses, automated emergency call and message notification call. That's what how to use a feature, right? Request and response. One feature, this is what like one feature, right? Smart vehicle could cache the recent response for future use. Once the response is received, it could be played on the display screen or displayed on the screen. Then user or owner be able to watch, okay, the manual or videos or learn how to use that particular feature without anyone's help. Okay. That's what, okay, internet telephone service provider networks 5G. This will send, okay, once the smart vehicle, okay, gives the some needs some help or want to know some feature or want to send some signal to the vehicle manufacturer, right, to get some response or help. Okay, this is what actually the communication case, okay, how a feature can be extracted, something like that. And so how to do basic troubleshooting, this is what actually smart vehicle how to do basic troubleshooting. And so coming to the sending request, right, so help of an automated bot service sometimes, okay, that is going to solve our request, or that is going to respond, okay, against our request. And then we'll give some sort of, okay, video, or we'll give some sort of material or some sort of help, okay, which is going to appear on the display, okay, LED display or something like that. And video response can be mirrored, right, to the users or owner's mobile device, which can be used for AR contents or VR contents, and even remote assistance also nowadays. These are all different features. Maybe you'll come across when once you go to advanced driver assistance systems and all. Okay, so if the user or owner is unable to fix the issue, then customer support representative can arrange or facilitate, okay, a service matter expert remotely also, so that or who is available nearest to the user, right, they are going to. And this pushes, okay, all these kind of problems to disappear, or okay, will be resolved, okay, within less time or less time, okay, within no time or within less time. So then coming to the integration of smartphones, this is also one kind of communication. So lacking today's mobility, strictly speaking, but smartphones to be, okay, I think slowly the technology is getting adopted, right? And uh, very soon we are going to see that, okay, smartphones integrated driver assistance systems, controlling smartphones functionality through voice commands or even buttons on the steering wheel. This is what Apple's Siri Eyes Freeze an app will allow usage of iOS from the dashboard of vehicle. And these are all apps, okay, and firmware specialized apps, okay, firmware to improve certain features like including radio, tire pressure, Wi-Fi connectivity, and charging capacity. That's what here, because charging networks, right? Firmwares improve the charging capacity of the, okay, battery, okay, being used in smart vehicles or hybrid electric vehicles. And this Tesla Model S, a 100% electric car, is one car that has such firmware updates. Okay, charging capacities are being notified, and even charging networks wherever near, okay, according to the map is traveling, okay, going to advise, okay, maybe 500 meters later, or within a 1 kilometer radius, something like that, you are going to have a charging station, so that immediately battery is to be charged or swapped with fully charged battery, like that. Okay, so going to integrate, okay, and going to respond, okay, uh, like this. And then what is AR head-up display? That is windscreen would add a lot of functionality. That's what display on a car windscreen, able to see speed, navigation details, and even name of an incoming call with minimal design. Like all these things, head-up display it is called. And display help to keep eyes on the road by giving all the relevant information,
స్లీపరా
okay, without necessity of looking.
సెమీ స్లీపర్ అయినా ఓకే నాకు ఏం ప్రాబ్లం.
Batteries, okay, is it
ఘాట్ రోడ్
changing?
కదా.
Batteries, okay,
Yes, sir, it's okay.
yeah, yeah, that's fine. Yeah, that's what I think. Somebody is talking different, huh? That they're talking.
చేసేసేయండి, ఎందుకు మళ్ళీ లేట్ అయ్యే కొద్ది ప్రాబ్లం.
So this is what actually batteries. Okay, when it comes to the batteries, maybe battery management we have to talk more on in the case of smart vehicles, and of course naturally batteries, bulk and heavy batteries, so that they should be balanced throughout and should be in safe okay condition, should be in charged state okay for long distances, and maybe here sheet thin batteries can solve okay that package battery package, as these batteries can be placed at any place, okay, can be okay throughout the car, both interior and exterior, and here maybe our attention is more required okay to make the batteries thinner, thin and thin, more thin, right, and bendable, something like that, flexible batteries kind of thing, and battery management systems, more and more technology integrated battery management systems, and dedicated, maybe even sometimes you can go for onboard charging and then Wi-Fi based charging, wireless. That's what wireless charging. Okay, provisions, right? We can make to avoid okay the too frequent charging, discharging. Okay, by stopping the vehicle. That's what, and onboard charges can be preferable. And here coming to the long-term evolution that also turn the vehicle okay into a Wi-Fi hotspot for people on laptops they can work for. And Audi have plans to implement LTE. LTE allow better quality internet radio searching for a location, something like that. And self-healing paint, that's what actually around for some time now, but somehow has not been implemented in consumer cars yet. Maybe for the other what you call commute public transportation and all, to some extent self-healing paints and all, whatever the case. Okay, here cooling technology, cool technology, because batteries, when it is okay, the vehicle is continuously running over a period of time for long distances and all, there's every scope that battery is getting okay heated, and safety aspect and all cooling technology. Not only battery, right, there will be motor heating and all, okay, surface heating, then peripheries and all, exterior, interior. So surface scratches will disappear after just a few minutes, and the car will look like how it once was. That's what self-healing paints will help, right? And smart fuel saving, fuel efficiency tips or notifications while driving. This is a cool feature, right, to give tips on fuel efficiency and how to save the fuel. Okay, smart fuel saving. Example, notify about a nearby gas charging station that has the lowest prices, something like that. Okay, and maybe off peak demand, something like that. Off demand. Suggest that refill now to avoid paying more at another station when it's run out of fuel, like that. Okay, they can, and of course there are various other value added services, as we call it as building data mining and AI solutions for okay being collected at the vehicle manufacturers cloud systems or cloud servers, which may allow for data mining and development of AI solutions, okay, fast and rapid solutions, so that manufacturer could identify a pattern for certain scenarios, that could help improve the current system design. This is what actually future smart vehicle. So components of future smart vehicle, I'll allow you just at a glance go through that. And here the connected vehicle, vehicle to vehicle, or okay, vehicle to internet, or vehicle to user, okay, vehicle to other transportation systems. Okay, that's what actually onboard unit. The future smart vehicles will be equipped with onboard units, and also smart rear view, smart braking assistance. Of course, we call it as nowadays in electric vehicles, electric braking, but here that assistance will be given for braking also. Okay, by just looking at the proximity of the obstacle or distance between the vehicle and the obstacle and all, right, smart braking assistance, that's what, and smart lights, fuel efficiency, smart parking assistance, smart lane detection, black box, that's what if anything happens that it is going to record, and of course smart rear view. Nowadays we are seeing that the panels and all, and infotainment, entertainment, okay, all these things, and these future smart vehicles will be more and more safe and more and more assistive. What we can say that for better driving experience and better lively experience, lively driving. That's what we can say. This is about actually a smart vehicle concept and connected systems. And just please wait for a minute. I'll present what are the sensors actually useful, and what is the IoT, okay, behind this smart vehicle and smart mobility, right? For smart mobility, I'm going to present. Just allow me a couple of 1 or 2 minutes. So meanwhile, any participants, anything or experience? Yeah, hope it is visible. I'll try at least this one slideshow. Is it appearing full view?
Sensor technologies.
Yeah, full slide or?
Yeah, it is available.
Oh, good, good.
Appearing, but not full. Only thing,
Not full,
same
no.
way, guys. Yeah,
Acha, acha. Same thing it is coming, right? Then I'll increase this one.
that's
Slide.
okay. That's okay, sir. No issue.
Yeah. So this is what actually in-vehicle sensors, what people are developing nowadays. The vendors, various manufacturers are developing in-vehicle sensors and applications, of course, in different areas, like take care of the vehicle safety, driving, maintenance, infotainment, traffic, even traffic management. So they are all implementing roadside infrastructure such as cameras. Of course, on the other side, government bodies and what you call the statutory bodies, what we can say that they are also what you call improving the roadside infrastructure. Okay, building the infrastructure such as cameras, sensors to collect data about environmental and traffic conditions. So that's what you see here. Both manufacturers and the statutory bodies are integrating these various types of technologies and infrastructure. Okay, with the help of the sensing devices or sensors and communication equipment, and then okay, intelligent devices or gadgets, so that making the entire system more smart or to achieve more smart system, like, okay, to for better safety. That's what. So here, this internet of technologies or internet of everything nowadays, okay, created many opportunities for developing sustainable, intelligent, and smart transportation or smart mobility. That's what. So that the safer traveling experience and migration to intelligent transportation is in place or is going to, okay, what you call, will be enabled, okay, in coming days. That's so focus on four fundamental principles. That's what. Okay, all these sensor technologies or the smart technologies or smart mobility usually focus on these four fundamental principles: sustainability, integration, safety, and responsiveness or reliability, something like that. Of course, on the other side, fuel efficiency, fuel saving, all these things. Of course, once you focus on this sustainability, maybe that takes care of that. Okay, fuel saving. So this one. And coming to the current number of sensors, currently the average number of sensors, if you look at a vehicle, maybe it's like semi-automatic vehicle, something like that, around 60 to 100 sensors, average number it is. But as vehicles become smarter, the number of sensors might reach even as many as 200 sensors or even 1000 plus sensors, right? That is what actually the sensors. And here, different types of sensors come under four categories, which are identified for this vehicles to make smarter or to become smarter. Sensors for safety, sensors for diagnostics, sensors for convenience, sensors for environment monitoring, and two more additional categories like driving monitoring and traffic monitoring. Of course, these are four major fundamental principles. And on the other side, right, you can add two more categories of sensors. So, driving monitoring and traffic monitoring. And this is what actually, so the safety, diagnostic, and traffic sensors. So, here, safety from the base of safety and focus on recognizing accident hazards and events almost in real time. These are the examples of safety category of sensors, or under the category of safety, these are the sensors actually: speed sensors, cameras, radars, laser beams, okay, even proximity sensors, ultrasonic sensors, okay, night vision sensors, haptic sensors. These are all comes under safety sensors. And this is what actually I told you, this ADAS, okay. So which is going to provide so many benefits like okay reducing or eliminating accidents through their enhanced monitoring and automated interventions, okay, so that incidence of accidents will be less, frequency of accidents or hazards will be reduced, recognizing, okay, or forecasting, even it forecast the accident, and thereby, okay, smart assistance in braking the vehicle, okay, in applying the brakes and all. That's what. So, and for improved traffic flow and all, right, that's what is going to make the sustainable mobility through this type of and even if you look at the Bharat, like NCAP, what is that? Adoption through initiatives like Bharat NCAP. You can check Google, right? New car assessment program and mandating ADAS features in commercial vehicles. So that's what actually is taking. Government of India is taking all these measures and okay, started initiation in adopting these type of ADAS systems in commercial vehicles, and it comes to the even okay, the consumer, that public transportation and all. And when it comes to the category of diagnostic, right,
ఒక పెన్ను పట్టుకో వైట్ పేపర్ ఇమ్మా
it's not for me, right? Yeah. Some voice I had.
టైను స్నాప్ తీయాలి.
Yeah. Others, please maybe mute, right? So when it comes to the diagnostic, these are the example sensors: position sensor, chemical sensor, even tire pressure sensors, right? So gas sensors, temperature sensors, and even airbag sensor, because airbags is also diagnostic. We focus on gathering data for real-time information about status and performance. Then traffic, monitoring the traffic like cameras, radars, okay, for traffic, which will improve the traffic management. And coming to the assistance category, okay, provide support for comfort and convenient driving or applications. So gas composition sensor, humidity sensors, position sensors, torque sensors. That's what. Okay, even brake sensors also maybe assistance. Okay, rain sensors, fogging, prevention sensors. Okay, then environment, under the category of environment. Okay, to monitor the environment, or what you call the temperature or moisture, the cloud conditions and all, right. And then user category focus on okay, detection of abnormal health conditions or behavior of the driver, which will deteriorate the driver's performance, or accident prone zones kind of thing, identifying. Okay, for this, these are the sensors like ECG sensors or EEG sensors, even heart rate sensors, thermistors. Okay, all these things will help. These are all actually, if you look at this image, one can understand very easily capture. So, what type of sensors? Different types of sensors at a glance, right? Humidity, temperature, motion, velocity, displacement, acceleration, tilt, electric magnetic leaks levels, okay, then flow, pressure, and then gas sensors. Okay, all these types of sensors, okay, are going to, okay, improve the user experience or driving experience, driver experience. Just give me a minute.
పనిలో ఉన్నాను.
Yeah.
Madam Srivani, please mute yourself.
Yeah. So here I got this Mauser.ch. Okay, I think China. I got sensor technology. I got this image, and these are all sensors for functions, manufacturing, transport, water. Because ours is transport, so position, presence, proximity, GPS. Okay, these are all various sensors, and homes and all temperature sensors, of course. For agriculture, these are the sensors. In vehicle, this is what actually I want to show you. In vehicle, what are the sensors, right? And this is from a reference paper I have taken. See that, okay, what nowadays people are talking about, okay, sensor technology for vehicles, and it's not that one or two sensors like that, okay. Under each category again a different specifications will be there: the GPS sensor, AC sensor, rear camera, fuel sensor, ultrasonic sensor. Sometimes, okay, for one single application, 3 4 sensors might be used integrated. Okay, so that is why around 200 sensors nowadays you are going to see, okay, in the smart vehicles, for the, okay, ADAS, advanced driving assistance systems, in the advanced driver assistance systems. Okay, this is about okay, in vehicle sensors. So infrared sensor, radar sensor, microphone is also a sensor, right? Inertial sensor and tire pressure sensor. Okay, so this is what actually, what type of sensor, okay, identifying will help develop applications that contribute to address the problems like traffic congestion, longer commuting times, higher levels of CO2 emissions, increase in the number of road accidents. So that's what improving vehicle performance as well as the driving experience, or enhancing the driving experience. See that tire pressure itself is an example, an application that is required for the National Highway Traffic Administration of the ES. Even our country is also slowly adopting this one, right? So if tire pressure is low, then it alerts. Okay, this type of sensing system alerts drivers through vibration or through light. Okay, warning if the tire pressure is low. Then proximity, ultrasonic, and electromagnetic sensors, parking assistance, or reverse warning applications. And the proximity sensors, that if any obstacle, vehicle closest to, okay, an obstacle, then proximity sensors. Then ultrasonic uses a type of sonar, so how far vehicle is from an object, alerting the driver. Okay, that's what. So electromagnetic sensors, so when an object enters an electromagnetic field created around the front and back bumpers. Then proximity sensors also develop a system based on rectangular capacitive proximity sensing array. So these are all types of these types of sensors are frequently affected by temperature. That's why sensors actually reliability, right, is also questionable. So that maybe a regular checking of the sensors functioning is also a precaution, right? A precautionary measure. And here radar, okay, radio detection and ranging, laser sensors, adjust throttle and activate brakes, right? That's what here actually. When it comes to the other in-vehicle sensors, gyroscope and accelerometer sensors. So in inertial navigation systems, so in short, we can call it as INS. Okay, for vehicle position, orientation, then velocity and all. So usually this INS in conjunction with global position GPS are used to improve accuracy. That's what. And okay, even positioning, like driver positioning, okay, through vibrations and all, because smart hat, smart belt, okay, smart seat, actually smart seat also. Nowadays people are working on smart seats, okay, driver seats, smart wheels, smart steerings, okay, people are working on smart steering systems also. Replace smart steering systems, even smart seating systems. One of my colleague, who is there in mechanical engineering department, actually is uh, graduated in automobile engineering, and of course later M.Tech in automobile vehicle systems. So he has developed a small prototype, a smart steering system. Yes, sorry, smart seating system, so which will identify the driver's positioning and all, and will give some alert or vibration or some warning, right? If the position of the driver is something like unusual or abnormal, okay, abnormal positioning. I don't know how many of you are, anybody mechanical or automobile engineers here attending this program. Smart seating system, please capture this word, triple S, smart seating system. Like that, smart steering system also. Smart steering system. Okay, all these different smart systems are being penetrated or being integrated into the smart vehicles for smart mobility. What? And here, monitor the driver's body posture, at position, eye activity, to detect any abnormal conditions such as signs of fatigue or vehicle behaving erratically, driving out of a straight line on the road, or pedestrians crossing suddenly in front of the vehicle. Even execute night vision assistance. Please think of, okay, these type of features are coming, that can cause, okay, that can identify, detect objects such as animals, people, or trees in the path. Okay, in the night, lidar, light detection and range, like radar, okay, has become in a key component for the evolution of autonomous vehicles. Light detection, okay, enables a self-driving car or robot, and with a few special characteristics like 360 degrees visibility. Okay, so here I'll take a minute to go through the some popular smart charging station options. And here the smart charging station options consists of like Emphoria Level 2 EV charger. This is what actually one type of smart charging station option. Emporia Level 2 EV charger. We can type, actually, you can check even in Google, you will get it, right? If somebody check it, right? Emporia, I'll make it Emporia Level 2, because our topic is like smart charging station. So that's what actually, yeah, we can get it. I'll show you this. It's like for Tesla or something like that. I'll share that one. I'll stop here and I'll share that. Is it sharing? Is it
Yes.
sharing the tab?
Yes, sir. Yeah.
Yeah. This is what Emporia classical level E2 charger. This is what, see that, okay, the connecting cable. Okay, almost after 2 years of use, this charger has exceeded my expectation. That's what they are giving. Okay, something like Randall. Okay, some review, verified Amazon review. Okay, that's all. So here, I think it is in Amazon. No? Okay. Directly, I'll go to Emporia Energy. Yeah. So this is Emporia Pro Charger with NACS Tesla style connector. So that here how energy management and all one can go through that. Emporia Energy, that is Emporia Level 2 EV charger with smart Wi-Fi capabilities and a 24-foot cable. Okay, charge any electric car quickly, intelligently, and safely. Okay, this is what here. Okay, a video also you can go through that, and this is best smart EV home charger by Motor Trend. Okay, the best EV charger for 2024. Okay, so these are all different. Okay, compare the classic and pro chargers. Okay, cable lengths and all it is given that installation NAMA and charging speed up to 48 amperes, up to 48 amperes, right? And smart scheduling, both are there, and load management only Pro. Okay, Emporia Pro, and this is what. So Emporia Pro with no expensive electrical panel upgrade plus extra energy management features. Okay, this one. So you can go through the smart charger. Okay, and next it comes to the Atal home level 2 EV charger. This is also one kind of smart charging charger, smart charger. It's also like kind of two-wheeler charging, and even smart home flex, that is 240 volts, and Evesco EVDC series, that is DC. Okay, these are all okay different types of okay smart charging. That means it's smart, some smart kind of charging. Yeah, just hope many of you know that what is EV charging station equipment. Anybody? Yes. What is EVSC? EV charging station equipment. Anybody? Yeah. So anyway, that smart EV charging stations usually 40 amperes and Wi-Fi. I'll share this one green light. Yes. This is also one kind of smart EV charging station. So 40 amperes Wi-Fi, 24 feet cable, and this is what the connectivity. Okay, for residential, and charging cable length and overall dimensions. Specifications, of course, one can download. This is greenlightusa.com, and mounting wall or pedestal. This is what like that. Okay. Greenlight smart EV charger provides up to 10 kilowatt of power to your vehicle. Maybe adjusted for 40 amperes, 32 amperes, 24 amperes, even 16 amperes maximum current output. So unit includes 24 feet premium output cable. That's what. Okay. And even smart EV charging station with Wi-Fi, Ethernet, 16 feet cable, like that. So you can all go through that. These type of okay, EV smart charging stations. And another, maybe in India, Tata, you can say that Tata Power. I'll share the Tata Power charging stations. Some details. Is it visible?
Yes, sir.
Yes,
Yeah.
sir. It's visible.
Chargers. Uh, Even these are all hyper connected charging stations. So 50 by 60 kilowatt DC charges. The very fast charging, level 3 we can say that, and connector types 1 and 2, and even for same connector types 1 and 2. Okay, so 240 volts connector type, AC charger, and E-bus charger, and 30 kilowatts DC or fleet chargers. Like the charging browsers, right? Brochures you can download and can go through the charging. They name it Ease Charge app and all. Those we have got Tata Motors vehicles. Okay, so that I think they are utilizing already this type of Ease Charge, EZ charge. So and ABB also we have got it on the other side. ABB. Because it is like charging network, so I thought of sharing couple of charging infrastructure developing manufacturers or infra developers. So there are some videos also, you can go through that. So AC, DC fast. DC fast usually starts from 50 kilowatt, and DC high power alone 90 kilowatt starts from ranging through to 360 kilowatt. And DC high power also. This DC high power all in one. This DC high power 175 to 350 kilowatt, and overnight sequential root panto up, root panto down, like that. Various ratings HVC. So home charging, then multi-unit, single unit, then workplace, retail, hospitality, service and delivery fleet. Okay, like that for different sectors, public transport. Okay, and of course you can go through their okay, charging care, service level agreements, and product life cycle managements. Okay, suppose public transport. Okay, you want to go through the public transport like this. This one, depot charging. This is called opportunity charging. Okay, this is what heavy duty. Okay, HVC 360 distributed power for heavy duty fleets. 360 kilowatt output, dynamically shared between 1 to 4 outlets. This is what charge dock dispenser maintains up to 500 amperes, and connect up to 4 dispensers to one power cabinet, that is 1 to 4 outlets. That's what. Install dispensers 150 meters from the power cabinet. Like that, if you click, okay, you will get the, and here these are the, okay, combine up to 4 dispensers, and depot charge box, and pantograph. Okay, the various pantograph down and pantograph up. This is streamlined bus charging, and it is vehicle mounted. And these are all flexible charging solutions they are offering. So like that, you have different charging infrastructure developers in our country also. Uh, so I'll go back to my presentation. Is it sharing? Anybody, please.
Yeah, say.
So those are all okay. So various sensors for traffic control presently being used or under current use, like non-intrusive and intrusive, like the two types. Okay, intrusive category and non-intrusive category. Intrusive category: pneumatic road tube, inductive loop detector, magnetic sensors, piezoelectric sensors. So piezoelectric for classification of vehicles or count vehicles, measuring vehicles weight and speed, like that. It is intrusive, okay, category, and non-intrusive like cameras, radars, infrared, okay, road surface condition sensors, even radio frequency identification (RFID) used to track vehicles mainly for toll management and all. Non-intrusive. So these are the images actually, intrusive and non-intrusive. Like, so these are all. Just I'll give a minute. Please go through the magnetic sensor, pneumatic tube sensor, inductive sensor, radar sensor. Right? These are all images. Laser beam sensors. Uh, the top figure is intrusive sensor groups like embedded magnetometers, pneumatic tube sensors, inductive loops. And bottom image is non-intrusive sensors, roadside mast mounts, mounted, bridge mounted, across roadside. Then communication sensors. I think it is coming around 10 minutes left, and let's have interaction. Yeah, like that. So I leave this one. This is what actually automotive applications. One can go through the automotive applications, different technologies. This is the website. Yeah, organizers, please. Let's have some interaction, something like that, before closing. I think 9 o'clock up to
Yes,
session
Professor.
ends at 9 o'clock, right?
Yes, Professor.
Yes.
Participants, if you have any questions, you can unmute yourself and raise your questions to the speaker. Feedback link has been posted in the chat box. All the participants are requested.
Thank you, Professor, for bringing such a vast information in such a short time to our knowledge. I am definitely, for me, things are very, very new, and I am thankful to you and grateful. It will be definitely useful if organizers send to me this information, because it's difficult to read and assimilate at the last day than day by day. Thank you so much.
Yeah, welcome, sir. It's my pleasure actually being part of this FDP, and though it is nth minute, but I was prepared, of course. And so, thank you very much for giving me this opportunity, and to thank both the institutions, your institute and my institute, Salam Alai, and my MESR. Thank you very much.
So nice of you, sir. Thank you.
Thank you. There is no other questions? Shall we close the meeting now? A PPT will be shared on the last day. I have told you yesterday itself. All the PPTs will be shared in the WhatsApp group on the last day itself. Thank you, Professor, for your informative presentation for last 1.5 hours. Hope
Yes.
participants might have got a few information about the chosen topic. I sincerely convey my gratitude on behalf of Salam College of Engineering for accepting our invitation and delivered a wonderful session for the Atal 6 days faculty development program. Thank you, Professor.
Thank you, sir. Thank you, one and all. Thank you for giving me this opportunity. Sir, I am leaving.
Yeah, yes, sir. Thank you.
Yes.
Thank you.
Sir, after putting the feedback, can I leave, sir?
Yes, yes, sir.
Thank you, sir.
Help.